Hi there. We're going to find the derivative of secant of x using our good friend the quotient rule, which I have provided for you here. If you think about secant as the reciprocal of the cosine function, you may realize that it's actually easier to find the derivative using the chain rule, and I'll leave a link in the description to my lesson doing that. If you haven't tried that yourself, be sure to check our answer in this lesson by solving the problem with the chain rule. Anyways, let's get into this method with the quotient rule. Remember, if we have the quotient of two functions, f of x over g of x, the derivative of that quotient is f prime g minus g prime f all over g squared. Let's use it. In order to differentiate secant of x using the quotient rule, your first thought would be, well, we'd have to write it as a quotient in order to use the quotient rule, and to do that just requires knowing the definition of secant. So the derivative of secant with respect to x, what's that? Well, we could replace secant with its definition. It's just the reciprocal of cosine. So the derivative of secant, that's the same as the derivative of 1 over cosine. So now we've expressed the secant function as a quotient, and we can bust out our friend the quotient rule just like that. All right, so let's do it. The first step of the quotient rule, in our numerator, we've got f prime g. Now f prime is the derivative of the top function. The top function is just 1, a constant, so f prime is 0. This means that what comes next in this part doesn't matter since it's getting multiplied by 0, but just for the sake of completeness, it's f prime g. F prime is 0, g is cosine of x, so let's just write that, cosine of x. So that's f prime g in the quotient rule. That's the derivative of the numerator function multiplied by the denominator function. All right, let's continue. F prime g minus g prime f. G is the function in the denominator, cosine of x, so g prime is going to be negative sine of x. Notice how I'm using a generous amount of parentheses here to help make sure I don't make any sign errors. So we've got g prime times f. We just wrote g prime. F is 1, so we could choose to leave it out, but just to try to make this work as clear as possible, I'll write that times 1 as well. That's it. That's f prime g minus g prime f, so we're almost done. Just got to divide by g squared, so cosine of x squared. And we are off to the races. Let's just do some simplification. So here in our numerator, we've got 0 times cosine, which is just 0, and then minus negative sine times 1. The negatives cancel out, the 1 doesn't matter, we're just left with a positive sine of x in the numerator. That's being divided by cosine squared there in the denominator, and just a little bit more simplification we can do here. I've rewritten sine over cosine squared as sine over cosine times cosine. It's the same thing, just want to make it super clear that we've got two factors of cosine in the denominator. And now we can finish this off. So we've got sine over cosine times 1 over cosine. Let me write that out just to make this super clear. We've got sine in the numerator, and we've got two factors of cosine in the denominator. So we could write that like this. Sine over cosine times 1 over cosine. And now we are just about done. Sine over cosine is, of course, the tangent function, tangent of x. And 1 over cosine, well, that's what we started with. That's secant of x. So this is tangent times secant, and in my experience, the derivative of secant is more often written the other way around. Order of multiplication, of course, doesn't matter. You'll often see it written as secant of x times tangent of x. And that is how we find the derivative of the secant function using the quotient rule. The derivative of secant of x is secant of x times tangent of x.
Further away is closer today, mobiles of the galaxy. Sun up to you is shadow to me with wires and memory.